For the third plenary, we have Dr. Bill Cobern from University of Western Michigan and Madison Institute of Science Education. Dr. Cobern has been active in science education for almost 50 years now, since his doctorate, and he has had 20 students to successful completion to their PhD degrees up until now. And 13 of them were from different countries, including Turkey, Saudi Arabia, Bangladesh, Brazil, Cameroon, China, Indonesia, Malawi, Pakistan, and Uganda. And many other master's students worked with Dr. Cobern. I know Dr. Cobern for his work in history and philosophy of science, and I had great pleasure reading his articles and benefiting from them and learning from them for a long time now, because it has been also my area of interest academically and personally. And Dr. Cobern also has contributed to scholarly works in the field of cultural and social study of science and the effective teaching of science. He has strong connections with Turkey. He likes to come here and indulge himself into sweets in the Turkish patisseries. He has some favorite ones in Ankara and Istanbul. And ladies and gentlemen, it's my great pleasure and honor to introduce you Dr. Bill Cobern.
Good morning and welcome. It's nice to see everybody here. It's, as Fatih says, I've been in Turkey now a number of times, and I always enjoy coming. It's a pleasure to be here at ESERA. This is actually the first time I have come to ESERA. It's great to see old friends like Fatih and Goltaken and Ebru. I'd like to thank the organizing committee for inviting me to speak today. And my topic is trust or distrust. I sort of flip back and forth between whether we have a distrust or a trust problem in science, but we have a problem. However, bearing in mind that the theme of this conference is connecting science with cultural heritage, there are a few places during my talk where I will endeavor to connect my remarks on trust and science with cultural matters or issues. Importantly, very importantly, the first cultural comment that I need to make is I present my work as an American science education researcher, reporting on trends and data from the United States. Furthermore, my language is obviously English. My point is that my remarks today need to be viewed in the context of where I come from. They need to be viewed in the context of American culture and the English language, and that's a limitation that should not be ignored. With that important cultural caveat said, let's move on to the organization of my remarks. I'm going to have a few introductory remarks. I want to say a little bit about the concern with trust, distrust that I have, that it's becoming a public problem. And I'm going to do this from a long-standing concern that I have had over how the nature of science has been taught. From this introduction, I will give a brief discussion of the research that we have been conducting and recently published in the journal Science and Education, their special issue on trust. And then I will present some new data from some of my research associates. And then thirdly, when I finish up, I want to propose some avenues for future research and some what I'll call prudent implications for instruction, even though this research is quite nascent. So let's begin. And I'll begin with a bit of personal history. The nature of science is going to feature prominently in my talk today. And I'm going to take you back to 1989, and that was my very first published research article. And of course, the 1980s was long before nature of science research came into its own as a popular area of research and an important component of science education. It was long, long before the Venus view of the nature of science and the broad acceptance of that view. And of course, it was much earlier than the relatively new family resemblance approach to the nature of science. I wrote this paper based on data that I had collected when I was teaching in Nigeria. I had come out of my doctoral program at the University of California in Boulder, University of Colorado, Boulder. I did my undergraduate work in California, where I had developed an interest in the philosophy of science as it pertained to the teaching of evolution. And I was also interested in cultural issues. So back in 1979, as I finished up my degree, I took a position in Nigeria. I don't know if you can recognize me or not. That is 40 plus years ago. And my hair is certainly a lot grayer today than it was then. At that time, the University of Sokoto was in temporary quarters. Oh, by the way, don't look it up because it's no longer called that. It's Usman Dan Fodio University today. Anyway, I spent 4 years there. And you can see it's the upper northwest corner of Nigeria. It's a very remote part of the world, but it gave me a lot of time to think about students and the learning of the nature of science. And it's curious to me that now as I come to the end of my career, because I will be retiring next spring, that in a sense I've come full circle with my published work, because my most recent published work is, of course, this one in Science and Education, which we published on the question of trust. My colleagues and I argued that the problem of trust was very likely associated with some of the things that we teach about the nature of science. So let's talk about trust. We had this question on our minds: do you trust science? And we had this on our mind because we were aware that various people would dissent from science. Our inkling was that an overemphasis on the tentative nature of science was creating a problem, that it was undermining students' confidence in science, that is, their trust in science. The science community probably responds that this all depends on what you mean by trust. Now, my clicker's falling apart. I guess it'll still work. The science community is going to respond, well, it's going to depend on what you mean by trust. But the public will oftentimes respond that, well, no, of course, we can answer this question about trust. And our answer is that we're not so sure that we can trust science. So I address the problem, the question of from the perspective of the public doubt suggesting that we need to change certain things about the way that we teach science. So now comes my second cultural caveat. My focus is on the teaching of science and specifically the teaching of the nature of science with respect to trust in science. However, trust is a very complicated thing, and trust in science is much more complicated than anything we could say about the nature of science. Consider this graph that was recently published by the Associated Press. Now, I know that the numbers and so forth can be somewhat difficult to read. I do have a text copy of this talk if anybody wants to see it, and the graph is in that. What I want you to notice is how flat these lines have been from the year 2000. Between 2000 and 2020, there's not much movement in these four lines, and they are relatively low on the scale. They're bouncing around 30% to 50% of the responses of the respondents in terms of whether they trust science or not. Now, there are 4 lines on this graph, and they represent the 2 major political parties in the United States. The 3rd line is political independence, and then the 4th line is the aggregate of the 4. So right away, we can see that anything that we might think about the nature of science, well, there is a political aspect. The Associated Press was drawing attention to the across-the-board decline in trust in 2022. You can see that the lines go along somewhat steadily, and then they start to bounce around, and then they drop off. And so it would appear that recent events have exacerbated the problem of trust, which again indicates how complicated, how many factors there are likely to be involved. So we as science educators and teachers, we can't do much about the cultural issues, but we can address how it is that we teach science and how our instruction can impact trust. So acknowledging that the problem is much bigger than our research and instruction community, let's look at our community. Our research rests on 3 questions directed towards our research and practice community. And all 3 of these questions we answer in the affirmative. Do we have a trust problem? We say, yes, we do. Does the science education community bear any responsibility for this problem? Again, we answer, yes, we do. And third, can we do anything about this? And again, our response is yes, we can. With respect to the first question, I'm going to talk about our data that led us to answering the trust question in the affirmative. But first, I want to argue that the problem is one of trust and not one of anti-science, which is a conclusion that some might come to. If you think back to the AP graph, the associated graph, keep that in mind. Back over the past 20 years, I doubt there's ever been much true anti-science. The public across the world, maybe even all the world, is very pleased with science that tangibly, and I emphasize that, tangibly improves their lives. So I'll give you some examples. Science that contributes to the engineering of better cars, yep, we're good with that. Science that contributes to the development of a medical device that keeps me alive during a critical operation, well, we're good with that too. Science that develops antibiotics that cure me from what would otherwise be a lethal bacterial infection, we're very good with that. The problem comes with the intangibles, and that is where vaccines become an issue. The science in support of vaccines is based on reams and reams of data. But to the public, that may or may not mean very much. I can take the vaccine, and according to the science community, I'm somewhat protected or very, very nicely protected, but you know, not always. And besides, I might not have gotten the disease anyway. We can make the same argument for the intangibleness of evolution and the intangibleness of climate change. Now, as soon as I say that, people probably will want to say, hold on, wait a minute, how can you possibly talk about the intangibleness of climate change? I mean, you can't even talk about the intangibleness of evolution. However, the public will say, maybe climate change, this is just natural fluctuations. Now, that's an explanation I hear relatively often. It's just natural fluctuations. Now, of course, I agree that the tangibleness of evolution and climate change are indisputable, and that climate change is serious. But that is not necessarily how it is viewed in the public. these things are not tangible the way a ventilator machine is tangible and the effect that that has on me if I'm sick. They are not tangible in the way a car is. I get my new car and I say, oh my goodness, how much better cars are now than they were before. The real problem is trust for the intangibleness of evolution, climate change, and vaccines. I have to trust the scientists, and I have to trust the science because I cannot see for myself so easily what they are talking about. Therein lies the problem. It's not anti-science, it's distrust in the intangibleness of science. So returning to my question, do we have a trust problem? The AP graph suggests that we do. Given the rise of vaccine dissent in recent years, that's what you saw at the 2022 end where the graphs fell off. How can anybody doubt that there is a public problem with trust? However, even before the pandemic, the problem was brewing. Again, think of the AP graph and what the trust data looked like as far back as the year 2000. Indeed, in 2019, Naomi Oreskes wrote a very interesting and provocatively titled book called Why Trust Science? At this point, again, somebody's going to say, oh, wait a minute, hold on. They may protest that the problem is not about the public in general. It's specific to those people who don't like evolution, who don't like climate change. It's about people who are opposed to vaccinations. That indeed was our initial thought. We began our research thinking that students opposed to evolution and opposed to climate change would show less trust in science than other students. So we looked at K-8 teacher education students who responded to items on evolution and items on climate change, and they also responded to items on the tentative nature of science and trust in science. We thought that dissenting students would be more inclined to say that science was tentative than other students. It would be a way of dismissing something that they didn't like, such as evolution. Well, that turned out not necessarily to be the case. In this slide, I'm actually showing 4 sets of data. So if we look at the top part, I'm only showing the students who had, I'm only showing the students with respect to the confidence in evolution question. So there are about 300 students in this study, and they responded on a 5-point Likert scale with 5 representing high confidence, and this was like high confidence in evolution, and then their confidence in the concepts of tentative nature of science and the concept of trust. We segregated, we segregated low-scoring students from high-scoring students on the evolution question. So in other words, we pulled out the students who dissented the most on evolution, and then a group of students who are most strongly affirming of evolution. All right, so out of 300 students, there were only about 19 dissenters, okay? Only about 19 who said, no, to evolution, as opposed to 150 that were very strong supporters. Now, we were not surprised to see the low trust mean for students who have low confidence in evolutionary theory. That was no surprise. We were, however, surprised that the mean for the high confidence students was not higher. So I've circled it here. The high confidence students, high confidence evolution students, it's better than the low confidence, that's for sure, but at 3.44, that was disappointing. That did not seem to be a very strong response on a 5-point scale. On the other hand, Both of these groups have high trust means, have high tentative means. So this study involved K-8 teachers, K-8 teacher education teachers. We thus wondered about teachers who are much more strongly science-oriented. And so a colleague of mine at another Michigan university ran a similar study, but her students were in a biology program. They were mixed majors, but they were predominantly science majors. They were overwhelmingly science majors. They were also demographically very diverse and much, much more diverse than our WMU students. These students were asked similar questions about evolution and climate change, but we did not separate out low responses because in fact, there were very few. These were all pretty strong science students. Once again, we see that the trust in science is much lower than the tentative response to the tentative nature of science. So these students showed themselves to be much more likely to say that science was tentative than to say that they trusted science. These students were also asked a question about accuracy that we didn't ask in the first study. And then to our surprise, the accuracy mean was the lowest of the three. A third data set comes from one of my doctoral students working back at WMU, working with 46 chemistry students, again, science majors, chemistry students. And they responded to the same set of questions. And if you look again, there is an emerging pattern, a trend. The low score is accuracy, the middle score is trust, and the strong score, the highest score, is the tentative nature of science. Again, we see that the students were more likely to think that science is tentative than they were to say that they trusted science or that it was accurate. And so lastly, this last set of data is simply a replication of the first study. And when we ran this study a year later, the same data was seen again. It was the trend continued. So yes, from these sets of data, from these 4 sets of data, we do think that there is a trust problem. And that brings us to the second question that our research group was asking. Does the science education community have any responsibility here? Are we somehow involved with this problem? And it's been my opinion that the question of trust in science is intimately related to the nature of science, and more specifically to how we teach the tentative nature of science. I suspect that it is how we teach the tentative nature of science connected with the sense of trust that students either become more trusting or less. It is certainly the case when science educators explain that the nature of science, it is in the nature of science that scientific knowledge is tentative, that it can change. What they implicitly mean is that scientific knowledge can never be considered certain. However, there is a subtlety to how the word tentative is captured, is used. There's a subtlety in how it is used in the science education community. And that subtlety is captured in a pretty well-known statement. Scientific knowledge is durable and yet subject to change in the light of new evidence and theory. The subtlety is that scientific knowledge always has the potential for change in light of new evidence, in light of new theory. However, or nevertheless, scientific knowledge can be quite enduring. It can be reliable and hence trustworthy for public policy, or even for personal decision-making. Regardless of this subtlety, however, it is the word tentative that is used repeatedly in the literature. Consider this. You can do a Google search for instructional ideas on the tentative nature of science, and you will turn up scads of examples. If you need a lesson example on how to teach the tentative nature of science, there is no end of the examples that you can find with a simple Google search. Try that with the durability of science. You get a very different result. And so it's the word tentative that I want to delve into now by looking at it semantically. And I'm going to stop at this. I'm going to say at this point that I stopped using the phrase tentative nature of science a long time ago. And later on in the talk, I'll say something about what I use instead. I want to take a semantic excursion into the word tentative. And it begins with another caveat. As I have already indicated, I'm speaking English, obviously. This is heavily dependent on the English language. Tentative, that is an English word. Native speakers of other languages, they need to carefully consider how these concepts are translated into their own languages and cultures. You know, I'll give you an example. Just recently, I've been talking with various colleagues, and four in particular, one from China, two colleagues here in Turkey, another colleague in Kazakhstan. They're all talking about how you use the English word tentative in their languages, and they're saying this is difficult, this is complicated. They could not think of an easy way to make the translation that fully captured what the nature of science indicates about this word. Moreover, there is literature, there is research literature that can give us insight into this semantic problem. Years ago, Masakata Agawa, a very fine science education researcher in Japan, published a set of interesting words on this very problem, this problem of translating English ideas related to science and science education into Japanese. And he noted that typically Japanese literature will translate the English word nature using the Japanese word shizen. The problem with this is that, as he argues in his papers, the problem with this is that for a native Japanese speaker, shizen doesn't mean quite the same thing as nature does in English. These words have what we call a semantic field, and the semantic field surrounding shizen has entities different from a semantic field surrounding the English word of English word nature. And as a result, a native Japanese speaker hearing the word shizen can easily think of this differently from a native English speaker. My point should be obvious that I'm speaking in English and I'm not presuming anything about other languages. My Turkish colleagues, they need to look at the English concept of tentative in light of Turkish language and culture, and the same goes for other languages. Furthermore, even amongst English speakers, there is a semantic issue. And again, I can explain this in terms of semantic field. Every word has a field of words associated with it. And I don't mean synonyms, because semantic fields can include words that mean very different things, but they are associated with the word. I'll give you an example I use in my cognition course. And I have a mixture of native speakers and some international speakers. And I will ask them to take the word moon, M-O-O-N, moon, and ask them, write down words that you think of, right? Well, I have yet to have one of my international students write down romance as an associated word, romance. But if you are a native English speaker, then the moon is something that you think of not just as astrological object, something up there in the sky, you think of it as a romantic symbol, right? So that's the idea of semantic field. Of course, semantic fields for native speakers overlap, but they don't overlap entirely. And so when I come back to the word tentative, science educators are imbuing that word with meanings that may not be in the semantic field of users. So let me give you an example of how our technical use of tentative in science education can be a problem in the public. So I'm going to give you a personal example. I have an uncle. He's a very dear uncle. I love him to death. He is not a science person, and he is definitely not philosophical. He is, however, very highly accomplished. I mean, he's retired now, but he succeeded in his field, and he's quite wealthy, all right? He made a lot more money than we professors did. So he was very successful. And it was a few years ago, and I can't remember why this happened, but he turned to me and he goes, "Bill, what is it? Is it the sun that goes around the moon, around the earth, or is it the earth that goes around the sun?" Of course, he's quite serious, because again, this is just information that's not particularly important to him. So I explained to him what you and I surely think is settled science. We don't have much doubt about this. Now, here's what I want you to imagine. Imagine that after I explain the sun-centered solar system to my uncle, I explain this to him, and then I say to him, yes, but of course, knowledge is tentative, and we may learn things in the future that will change our ideas that we have today. So my uncle would be flabbergasted. He would simply be flabbergasted. And he would tell me that I didn't know anything more than he knew. That's what he would tell me. He would not be impressed at all. Now, the second part of this little story is that a number of years ago, I was speaking with one of our doctoral students. And this doctoral student was well-versed in the nature of science. In fact, his doctoral advisor was a well-known nature of science researcher. So his creds were good in the nature of science. But I turned to him and I asked him this question about the heliocentered solar system and the Earth going around the sun. And I said to him, "So is this an example of the tentative nature of science?" Right? He immediately, without a hesitation, no hesitation at all, he responded, wait for it, he responded that it was. Oh my goodness, my uncle would not have been impressed. And I don't even want to say what I think he would say. All right, so what I'm illustrating here is the difference between a philosophical and a practical approach to scientific knowledge. Yes, of course, we know that from epistemology that you can hardly prove anything, right? Philosophers speak of the underdetermination of theory because they know that we can never have enough information to absolutely rule out all possible changes. On the other hand, inductive reasoning is powerful, and it is essential to survival. If we don't learn from experience, then we're in trouble. In that case, if I tell my uncle that there is a certain piece of scientific knowledge that is tentative, he's just going to tell me to come back when I'm certain. That's what he's going to say. In the public, our use of this phrase, the tentative nature of science, I'm afraid, easily undercuts confidence in science. And I think evidence of this has been growing for years. We saw it first with evolution, and then we saw it with climate change descent, and now more recently, we are seeing this with the vaccines. Does this matter? Is this important? I think that it is. I think this cartoon speaks loudly. Okay? It speaks loudly about this point. Dissent from science, distrust of science, oh, okay, sometimes it is warranted. However, it can be a deadly mistake. I'm not going to say that science and scientists are always correct, that they're perfect, because obviously that is not true. We know that that is not true, but trust in scientific data is generally a good thing. Consider the recent tragedy here in Turkey and in northern Syria. In this table, this slide, you see fault lines. There's nothing new about this. Knowledge of plates and fault lines has been in the scientific domain for a long time. We have known for a long time that scientifically, we know for many years that earthquakes predominantly occur along fault lines. Theoretically, true to the nature of science, we could say that this knowledge is tentative. And it is certainly the case that when it comes to predicting earthquakes, well, predictions remain elusive. But shall we say that this is tentative, even though scientists have little uncertainty about the role of fault lines with respect to earthquakes? If we do, then I think we're back to this. I think this is what we risk. I ask again, does the science education community bear some responsibility for the declining public trust in science? I think the answer is yes, because when we do not explicitly teach the grounds for confidence in scientific knowledge, we undermine confidence through the way that we teach the tentative nature of science. So let me come back to my questions. My third question is, can we do anything about this? And this leads me to the concluding part of my talk this morning. I want to begin with research. In brief, well, I can name any number of areas for research, but I've got three in mind. The first is replication, but I'm not going to say a lot about replication. I am a big believer that our work needs to be replicated. That's one reason why we have run 4 studies using similar techniques, using various techniques to see, with our hypothesis being, do you get this trend? If you, in different situations, in different contexts, getting data replicated is an important way of having confidence in your work. So I do think that this needs to be replicated. I by no means would presume that the distrust that we see in the US is common, say here in Turkey or other places. These studies need to be looked at, need to be repeated. I'm more interested right now in the concepts. The concepts that we use is a critical area for research. And right now I'm thinking about tentative, I'm thinking about the bipolar phrase or word certainty, uncertainty, accuracy, trust, reliability. None of these is a specifically scientific term, and there are more we could name. None of these is specifically scientific. They all are common English words, and the public comes to these words already knowing something about what they mean. The science education community If our community decides to use these words in ways other than how the public typically uses them, then we've got a problem. So as an example of a research, avenue research, I'll briefly describe work that Professor Ebru Muwalladu, I don't know if she's here in the audience, but Ebru and I are conducting at Boğaziçi. We are currently investigating the public understanding of the word tentative. And we are doing this by first modeling what we think the word is like in the public. And we will use that to develop an instrument then for research purposes. So our model, which is based on interviews and literature reviews and a number of other things, our model has this 4 components. And what this model says is that in everyday use, people will think of tentative in this way. Something is less tentative the longer it endures, which is, of course, not what the nature of science means. Saying something is tentative indicates that it's likely to change. And again, that's not what the NOS community says, or nature science says. Tentative suggests an element of quality. Things that are tentative tend to think of them as less quality than other things. And of course, that's not the NOS meaning. And then finally, context matters. People shift their use of tentative with respect to the context, and that's not how it's thought of in our literature. Our hypothesis is that ordinary people are more likely to use the word tentative in these ways than they are the way it is used in the science education literature. Stated another way, our hypothesis is that what the science education community intends to communicate using the word tentative is unlikely to be understood that way in the public. We will have data soon, and we will find out. As I mentioned earlier in my lecture, when working with students and teachers, I stopped using the phrase tentative nature of science a long time ago. Epistemologically, I could never evade the feeling that this just wasn't quite right. And so I used the bipolar term, certainty, uncertainty. I know it's more awkward, but I am convinced that it better suits what we mean when we talk about science. So I encourage you to try it, and I think there's some interesting research that can be done in using that term. Okay, then I want to say something about the integrated nature of the nature of science. And I'm going to focus on the VNOS because it remains the most popular framework for looking at the nature of science within the science education community. And I'm not by any means slighting the family resemblance approach, because actually, if I adjust my remarks just a little bit, I could apply them to the family resemblance approach as well. I want to begin by saying that the genius of the VNOS approach to the nature of science is that it distilled that nature into some relatively simple statements. And these statements then become teachable, and they also become measurable outcomes for research. And I've been in this business long enough to know this, there is little question that there is far more research on the nature of science. There is far more teaching of the nature of science today because of the VNOS work. It has been tremendously influential. The problem is actually the very simplicity of the VNOS approach, in that the nature of science isn't that simple. Even if the 7 statements are valid, they are not valid as standalone statements. They need to be interrelated. People might understand each of the statements individually, but then be misled by actually thinking of them individually. There's a I can give you a parallel example from some research. This is actually from a number of years ago, but some research on how primary students distinguish between living and non-living. I'm being told to hurry up. Okay, I'm going to finish with it. So some primary kids were taught a lesson on what it means to be living. And they're taught that things that grow, that reproduce, that react to stimuli, and that use energy. That's how you tell that something is living, right? Well, here's the problem. When these students were then asked about different things that were living, they came up with things like this. Well, maybe the sun is living. Because why? Well, living things use energy, and the sun uses energy, so maybe it's alive. They use the same thing with motion. Reacting to stimuli means movement. Well, we know that the sun moves. Maybe the sun's alive. But you see the problem. The students grasp the elements, they grasp the bits and pieces, but they didn't put it together. They weren't taught how to put it together. We run into the same possible problem with teaching the nature of science. If we don't teach the pieces together, if we just teach it piecemeal, especially if the idea of the tentative nature is taught piecemeal, then it becomes relatively easy to see how this can undermine confidence in science. Okay, I'm gonna go on to talk about some interventions. Obviously, this research is very early, and it's not that we can have a lot of definite ideas, but I think there's some prudent things to be done. And the first of these is teach data. Teach data. We need to teach the reliability of data. We need to have our students see data, to manipulate data. They need to learn how data is the foundation of, on which science is built. And I am not shortchanging the role of theory, but theory is not going to build trust. You have to remember that when somebody wants to dissent from evolution, a very common thing for a person to say is that it's just a theory, okay? I'm throwing out evolution because it's just a theory, right? So theory is not going to build trust the way data can. Data is far more difficult to simply dismiss. So I would focus on teaching data. And I would be sure in teaching the nature of science to integrate the various aspects of science and to continually bring it back to its empirical nature. And finally, with the word trust, I wouldn't shy away from the word trust. As far as I know, science teachers rarely ever bring such a term into a lesson, but I think it's time we do. We need to begin to talk with students about how it is that that trust is built from the data that we have. All right, so that brings me to the end. Do we have a trust problem? I think that we do. Do we have any responsibility? Yes, I think that we do. Can we do anything about this? Yeah, even without a lot of research, I think there's some very prudent things that we can do in our teaching, and we should do that. Yeah, we should all realize that the problem of trust is far bigger than our community. I mean, the waxing and the waning of trust, that varies with culture, with political issues, but we should not stand back and think that we cannot do anything about it. We should do what we can. And for my part, I'm very concerned about how we have come to use the word tentative. And so I'm orienting my research in that direction and my teaching to alternatives. And why do I want to do this? Because I think that's a problem. I think that is a problem. And if we don't do something different, then we are not contributing to the solution of that problem. Thank you very much. That's fine. It's up to you. Okay. It's up to you.
We can have maybe one or two questions if you like. Yes.
Thank you very much for the really illuminating talk. My question was how you exactly define the concept of trust in science in your work and more in generally, because I think there might be very different object of trust in the context of science. So when you say someone trusts science, that can mean very different things. For example, someone can trust scientists as people, the scientific community as a group of people.
Yes.
And also you can trust in, you can trust scientific knowledge, you can trust the scientific process. So I think generally like, trusting something and trusting someone are very different things. And I think this distinction can have like very important sort of implications for teaching the nature of science and science teaching in general. So I just wondered your thoughts on that.
Oh, well, I certainly agree with you. And we view our research as quite basic, exploratory. And because again, we were taken by surprise with the trust data that we had. However, I should say, and I didn't have time to go into this in the talk, that we did something unusual in designing our research. We actually went to the business community, to the research that's done in business on for companies and products. And if you go to that literature, what you'll find is that the business community invests a very large amount of money with evaluation companies, the Edelman Trust Group is one of them, to determine to what extent the public trusts their company. So here in Turkey, there's a company called Jumbo. They make kitchen things. Yeah. Okay. Good. We have a couple of. We like them a lot. Okay. A company wants to know that the public trusts it. Now they don't care how that word is broken down. They look at trust as a basic gut human instinct, that you trust something from your gut or you don't. Now that doesn't mean that there's no merit, profit into delving into trust. I think that there is, but there's also merit looking at it from the point of view of businesses. What's somebody's gut reaction when the word science comes up? And that's the approach that we took. But I would say the extension then gets into what you're talking about. Does that help?
One more question.
Yeah. By posing the question of trust in science, you have been actually talking about the paradigm of critical rationalism, which stresses the tentativeness of all hypotheses, right? Mm-hmm. Indeed, when you think of Popper's philosophy of science, it would be very good to counterpose it with the inductivist approach, which stresses that science is a justified true belief. Mm-hmm. According to Popperian view, science is unjustified, untrue unbelief, right? So this is the problem that you have been stressing. Now, it seems to me that there's an answer, perhaps paradoxical answer to this, which could be going along the line that science deserves to be trusted insofar as it is being based on systematic distrust to scientific hypotheses. Perhaps this could help.
Yes, I think so. And I wanted to say a little bit more about certainty and uncertainty, and your comments about Popper remind me of this. I come to my research committed to the idea that basic human instincts and emotions are really important. And we tend not to look at them, but we need to look at them. So here's one. Virtually everybody knows that nothing in life is certain. No, everybody knows this. Nothing in life is certain. So we are natural doubters, you might say. But we also know that some things are more certain and some things are less certain. And we need to learn how to apply, in science education, we need to learn how to teach the use of this range of certainty to uncertainty. You know, what is the role of doubt? But when does doubt begin to recede and affirmation become more important?
Bill, thank you very much for this inspiring and wonderful lecture. And don't go. Bill, I need you here. Bill, I need you here. The theme
Our
of
president did that at a news conference recently. Walked off too soon. Yes.
The theme of this year's ESERA conference is connecting science education with cultural heritage. So I would like to say a few words about that. Trust in science is in the DNA of our republic. Because our founding father, Atatürk, said, the truest guide in life is science. So this may bring another aspect to think about how to trust science. And another thing is this land has been a cradle home for many civilizations, and among them we had the Hittites, and they lived here about 4,000 years ago. And in order to, can I have you on my left-hand side, Bill? Okay. To connect cultural heritage with science again, this is a wine jug from 4,000 years ago. And you may ponder more about science education and cultural heritage if you like to have your wine with this.